Good morning, good afternoon, good evening, depending on where you're watching this video from. You're welcome to EK Math Academy. Today's topic, I've started my series on probabilities. So today I'm going to work on discrete random variables. My next video will be past paper questions on continuous random variables. Today we are going to work out past paper questions on discrete random variables. So today's topic, discrete random variables. They are past paper questions, understanding the key terms, and what do you need to know in the exam. Okay? So without further ado, let us try to dive into this and we start doing this topic. So discrete random variables. Now, let me start with the definition. So discrete random variables is just simple, in simple words, it's just a variable that we're going to take a specific separate variable. For instance, it's taking a specific number. It's opposite of continuous random variables. Okay, maybe let me use an example here for you to fully understand what I'm talking about. So for instance, if I'm tossing a coin, if I'm tossing a coin, one coin, if I toss it, what are possible outcomes? Let me say my desired outcome, I'm just interested in the outcomes to be getting ahead. If my aim is to get ahead, so what are the possible outcomes? So it's one coin, right? That means my outcome is going to be ahead or a tail. But if my objective is to get ahead only, that means my possible outcomes would be I may not get ahead or I get ahead once, right? So how do we write that one? That one mathematically, we write it as x, small x, guys, sorry, here, small x, okay? And then here, you have capital X, then small x, okay? Now, the possible outcomes will be 0, not getting ahead. That means I've got a 10. Or you can get one head. So what's the probability of getting no head? It will be 1 out of 2, guys, okay? What about getting one head? Will be 1 out of 2. So do you check the probabilities now? When I add my probabilities, I'll get out of 2, which is the 1, okay? What about if I toss 2 coins? What if I toss 2 coins? And my main objective, I'm trying to know, in these 2 tossed coins, I'm going to get ahead how many times? First of all, let me list the possible outcomes. I can get ahead. Is that okay? I'm tossing my coin 2 times. I can have a head and a tail, or I can have a tail and a head, or I may not get ahead at all. That means I'll get tail in the first place and get tail in the second place. Do you understand the sample space here, guys? These are my possible outcomes here now. I would like to draw the discrete random variable table, which will help you to understand what I'm talking about. Now, here, remember my main objective is how many heads am I going to get. So the possible outcomes, I may not get ahead at all, right? I may not get ahead at all, okay? I'm coming. I'm going to start doing past papers in the next few minutes, okay? I have them there. Just be patient with me, okay? I just want you to understand. I may not get ahead. I may get head once, as you can see. Here, here, no head at all. Here, do you see? For this one, I don't have a head. Here, I have one head. One head. Here, I have 2 heads, okay, on my coin. Those are the possible outcomes. So what's the probability of not getting ahead? Will be 1 out of 4, guys. Is that okay? What's the probability of getting ahead? Once. I can get it here. 1, 2 out of 4 possible outcomes. So the probability will be 2 out of 4. I hope you understand that. Now, what about getting ahead on 2 times? That means it will be here. So it's going to give me 1 out of 4. Again, guys, what's the sum of the probabilities? 1 over 4 plus 2 out of 4 plus 1 out of 4. Is that okay? So the probability, guys, is going to be 1. So, one more time. Discrete random variables is just simply is where the desired outcome is going to take a numerical value. Most of the times can be an integer or a decimal, but it's going to be taking a specific value. So it's not continuous. It's not like time or height. No, it is not. It's taking a specific value. I hope you have understood that. So I don't have time to do that, but you can try this. Okay. If I toss a coin 3 times, if I toss a coin 3 times, what are the possible outcomes? The possible outcomes I may not get ahead. I may get ahead once or twice or 3 times. Now, what are the possible outcomes? The possible outcomes in my sample space, I'll give you the formula. Try to write them down in the comments and you tell me what are the possible outcomes. The probabilities of each outcome here. The possible outcomes will be 2 power 3, which will be 8, okay? Now, if my possible outcomes are 8, what will be the probability of getting 0 head? What will be the probability of getting 1 head? What's the probability of getting 2 heads? Or what's the probability of getting 3 heads? See you in the comments, please. Okay? Thank you very much. Now, if you have understood what this discrete random variable is, after knowing that it takes a specific value, numerical value. Another important thing that you need to know, every probability, every numerical value is going to have associated probability. Like for instance, 0 goes with 1/4 here, and 1 is 2/4, and 1/2. So every numerical value has a specific value. The probability can be 0, but it has to be between 0 and 1, because there's every probability can never be a negative, can never be greater than 1. And that's what you're seeing here, guys. Okay? The condition and the sum of the probabilities to be 1. That is what you're seeing here. The sum of all probabilities should always add up to 1. Are we together? Any question? Just write in the comments. EK Math, we love mathematics. We enjoy teaching mathematics. Now, after understanding that the discrete random variables, they take a specific value and they have a associated probabilities, and the sum of probabilities is 1 of all probabilities is going to be 1. The next thing to know is what we call expected value. Expected value. How do we calculate that? We just get the sum of product of x values and probabilities. For instance here, should I do it here, guys? Just see. Like for instance, if I want to get the expected value, what do I expect? The mean. If I have tossed a coin 2 times and I have such a probability tables, what do I expect on average to get? That one will be 0 times 1/4 plus 1 times 2/4 plus 2 times 1/4. I hope you understand what I'm talking about. You just get, these are my x, this is that. That is the x times the probability. So the x value here is 0. What's the probability corresponding to 0? 1/4. That's why I did 0. This is 0 times 1/4 plus 1, which is this x value, times its corresponding probability, which is 2/4. Then 2, the x value, times the probability corresponding to that. Is that okay? That is it. Have you understood now? That's expected value. Now, what about the variance? Fast forward. What about the variance? So the variance is given by this formula here, okay? Expected value, you already know how to get it. The expected value, this time around, if I can use the previous question, right? We had small x. Let me use that example. And the probabilities were capital X, guys, small x here. And then we had 0, 0 head, 1 head, and 2 heads, right? So what was the probability here? 1/4, right? What was the probability here? It was 2/4. Okay, and then here was I'm talking about this table, guys. Okay, this is the table I'm transferring on the next page. Now, how do I get this? I already showed you. This is the formula to get the variance. Okay, I hope you know what a variance is and the standard deviation. The first part of probability, of statistics, you did that one. Okay, good. Now, how do we get that? As you can see, it's x squared. So it's going to be 0 squared times the probability of that, which is 1/4, plus, here I'm talking about this one, okay? I'm referring to this, guys, okay? Plus, the x value next is 1 squared times the probability of 1, which is 2/4. Okay, do you get that? Plus 2 squared times the probability of that. That is it, how we get this. You square. That is it, what this means. Okay? I hope you have understood that. And then after getting your answer, you take away the mean squared. This is mean squared, which you have already learned how to calculate. Okay? And the mean is here. I've just given you the formula, and that's how calculating variance. Now, what about the standard deviation? Standard deviation is the square root of variance, and what is standard deviation is the I hope you know that one, but I can say it in simple words. Standard deviation is the spread out of your data. It measures the spread out of your data from the mean. Now, whenever you're doing discrete random variables, it's better to know what we call transformation. Whenever you have such a values, for instance, if they say find and then they say 2x plus 2. I'm just giving an example of the previous question. What do? You just do 2 times expected mean, you get that? Then plus 2. You get that? You get your mean times 2, then plus 2. Okay, you get that? So this is the transformation of that. So for instance now, if I say find the, let me say find the variance of I'm just using the bracket 2 capital X plus 3, for instance. Okay, what does that mean? It means you just, this is my A, this is that, this is the A. It will be 2 squared times the variance of your question, the variance you already got. That is it. Now, this is what you have to know. Adding a constant does not change the variance. Adding the number here, the number you're adding there does not change the variance. Your variance will stay the same. But if your multiplying was the constant number, it will change your variance by squaring the number you're multiplying at. That's A, the effect of A. You should understand the effect of A. Okay? Very good. Thank you very much. First paper question. Okay, this is the first question. I have very many other questions here. There are more questions. Okay? Right now, I'm going to try to do this question. Are you ready, guys? Okay, let us try to do the question, and then we see if you have understood what we are doing. Now, a discrete random variable X has a probability distribution given by that. They told you that your X value, these are, you see, they are taking a specific value. And then this is 0.5, 1.5, 2.5, and 3.5, and they have their corresponding probabilities. And the expected value is given by that. Determine the value of P and Q. Doing this question is not a hard at all. The only thing you need to know, there are 2 things. How do we get expected value? And remember, the sum of probabilities should always be equal to 1. That's what I was talking about here, guys. The probabilities all the time add up to 1. In the exam, they will never tell you that. You should be knowing that. Okay, what are my probabilities now? It's 0.15 plus 0.21 plus P plus Q altogether plus 0.13 plus 0.07. This one should always give me 1. So can we add 0.15 plus 0.21 plus 0.13 plus 0.7? 0.07. What are you going to get? You're going to get the 0. Use your calculator, guys, and confirm that. You're going to have by 0.6 plus P plus Q should be equal to 1. Then correct like terms, you get P plus Q equals to 1 minus 0.56. Altogether here. And then what do I get? I'm going to have P plus Q equals to 0.44. Fast simultaneous question, guys. Okay? Altogether. So the first trick in the question is to know the sum of these probabilities is going to be 1. So that's why I got 0.15 plus 0.21 plus P plus Q plus 0.13 plus 0.07, and I equate it to 1. Because for these probability tables, the probability should always add up to 1. Then they gave you expected value. Now, how do we get expected value? Back to the formula. Expected value is given by that. So we have to apply this formula. This is the formula you have to apply, and then we form another simultaneous equation, and then we solve the equation. Are we together? Now, fast forward, it's going to be remember, it's going to be that times that. So it's going to be 0.5 times the probability of that was 0.15, right? Plus, okay, plus, maybe I can do something here. Let me do something for you guys. Just a minute, some seconds. Let me do something for you to see what I'm doing here. Okay. Let me take this one for you. Okay. Good. Okay. Okay. It's not working. Let me proceed very fast. There's no problem about that. Okay, good. Now it's going to be 1.2 plus 1.5 times the probability corresponding to that, 0.2. Okay. Fast forward, the next one is 2.5 times P. That one is okay. It's easy to do. 2.5 times P, that gives me P. Plus the next one has Q is 3.5. 3.5 Q plus the next one is Z, 4.5. 4.5 times Z, 0.13 altogether. Let me confirm, go back to the question. Yes, 4.5 times 0.13. So the next one is 5.5 times Z, 0.0. So I'm going to get 5.5 times 0.07. Okay, very good. Now, this one should be equal to expected mean, a mean expected value, which was given. What is the value given? It is 2.16, the expected mean. Do you see? It was given it here. I hope you understand that. Very good. So the next thing we have to simplify. Use our calculator. Can you confirm, please? You're going to get in your calculator, get this times that plus this times that plus this times that plus this times that. If you work out that, let me do it very fast. Okay, times Z, whatever, yes. So when you work it out, okay, it's giving me 1.36. Oh, sorry, guys. 36 plus 2.5p plus 3.5 Q altogether. I hope you understand. If you have any problem, just write in the comment. 2.61. Correct like terms, I'll get 2.P 2.5 plus 3.5 Q equals to 2.61 minus 1.36, and you get 2.5P plus 3.5Q. Altogether, guys, I hope you understand. That will give me equals to, when you subtract in your calculator, because this is a calculator question, it will give me 1.25. Okay, let me just confirm one more time. Yes, true. Second simultaneous question now. I need to solve my two simultaneous equations. Okay, so what are my two equations? P plus Q equals to 0.4 and 2.5P plus 3.5Q equals to what, guys? Is equal to, oh, sorry, here I made just, it's supposed to be like this. Okay, so 1.T in your GDCs, apps 9. So I put that on your GDCs, depending on the GDC you're getting. So if you use your GDC because the paper 2, you're going to have the answer for the question is going to be 0.29, and the value of Q is going to be 0.15. That's the value, right? Okay, I hope you have understood that. We have done question A is over. Question 2, find the variance. So do you remember the formula for variance? We say the variance is given by, that's the formula, right? Squared minus the mean. We already have the mean, guys, okay? That is the formula you're supposed to use. It's the formula given here. Do you see that? So what does that mean? This basically means you're going to get 0. Just 1 minute. Okay, 0.5 squared. There's a point there. Okay, point. 2 seconds. Okay. Let me write it very well. Sorry, guys. Sorry. 0.5 squared times the probability of that. Okay. 1.5. Okay. Let me just try to hurry up very fast. Okay. Plus, what do we get next? Plus the next value is 1.5 squared times 0.21 plus 2.5 squared, right? Times the p-value. Remember the p-value we got? We got 0.2. The p-value is 0.2, 0.29, okay? Plus the next it is 3.5 plus 3.5 squared plus times my bad times the q value, which is 0.15 plus 4.5, guys, times z, it has to be squared, times the probability corresponding to that, 0.13 plus 5.5 squared times 0.07, okay? Now, this one minus the mean is 2 point, the expected value, we got that one squared. When you work out that in your calculator, you are expected to get the answer as 2.10. Because if you work out that, it will give you 8.91 minus 2.61 squared, and that is your variance. Some exams, they will ask you standard deviation, then you do square root of that. Okay? Thank you very much. I'm going to do the second video on this question. So thank you for watching. Thank you for listening. EK Math, we love mathematics. Like, share, and comment. Stay here. I'll help you to understand mathematics. My next videos are going to be on the continuous random variables. Okay?